So, yes, hello. I'm David Marshall. I'm a postdoc working with Michael, and I'll be mentioning this demo. It's an excellent little introduction, where our core idea is that we're trying to create some sort of distributed trust system. We want to be able to not just have one single hierarchical system that's going to just suddenly need the entire world to trust, because that's just impractical. Right. So this is all based on identities, where these will be certificate verifiable credentials issued to anybody within our system. These could be sailors, ships, organizations, whatever. And like I said, these are verifiable credentials which are currently using the PECI system, so proprietary technology. But we may be moving past this, but for the time being, what we're going to be demonstrating today is based on this system. And when we have these identities, we can use these identities to define relationships, such as if we have these four identities at the bottom, identity 1 here on the left being this ship's captain, he could trust identity 2 with some property, some relationship which I've just termed A, because this could be anything. Kind of going back to Michael's comment of we're not designing what trust relationships actually are issued, we're just kind of providing a system for organizations to define their own relationships. Once identity 2 has been trusted with some identity A, it can give some subpolicy A.B, and then we have I1 has effectively delegated some A.B to identity B without ever having to have any sort of direct relationship with it. Okay, yeah. Yes, and then so what we want to be able to do with these is when we are wanting to access and use our system, that any of these identities should be able to come along with these trust relationships, which are themselves verifiable credentials, and present those relationships as kind of proof of who they are trusted by without needing direct trust between every single person within the system, right? And so we can layer these relationships as much as we want to in some quite complex sort of systems, such as this graph, which is quite a lot. Now, this is a scenario that I have kind of construed of how I, as someone who is very much not a sailor, might imagine that this system is all kind of operating. So it's designed as representative, but not gospel. Yes, and so what this is really is a decentralized system establishing two trust relations. The key trust relation is between our ship and a VTS system. Say our ship is just sailing through the sea into some new area, it needs to establish contact with this VTS. Now, it doesn't have any sort of predefined relationship with them, that's entirely what we're trying to avoid, but each of these components does have some pre-existing relationships with some trust anchors. So, let's discuss them a little bit one by one. We want to say that a VTS is designed or manufactured by some sort of certified manufacturer who can set out some technical specifications which they're meeting. So the ship, rather than having to just trust every individual VTS system, just needs to trust whoever is first issuing those technical specifications, which is what we can see happening on the left here. Just trusting that organization, which it then can then go down to trust the manufacturer, which then goes down to trust whatever software is running it, which then actually provides some trust to that VTS system. So we have one continuous kind of hierarchy of trust from this trust anchor down to this VTS system. And as long as our ship trusts that trust anchor, then we're okay. Now that wouldn't be a very interesting scenario if it's just one, so we've got some other ones as well. Equally, we might want to say that VTS areas, maybe it is credited, that's not quite the right word, backed up by whatever national government is running that relevant area. And equally, maybe needs to be operated by a trained operator. Say we've got three separate relationships where if our ship wants to get a valid, or if our VTS wants to be able to provide its service to the ship, then it just needs to provide proof of all three of these relationships together. And any one of them is not enough for us to say that that's a valid VTS system, it's only a combination of all three. Again, this being an illustrative example, what these relationships actually are, very much up to debate. But most of our systems will want to have some sort of two-way exchange. We don't want to just say that necessarily the VTS needs to prove who it is, the ship would also need to prove who it is. Equally, or similarly to the operator operating our VTS system, we might want to say that it has a qualified crew, including, for instance, a captain and a navigator, where these have to be hired by some sort of crew company and qualified appropriately. So interestingly, note the navigator has got two trust relationships, both by being employed and being qualified. So again, he's only a qualified navigator, or an appropriate navigator for that ship, if he's got both a reason to be there and is actually qualified. So we can begin to start expressing more complex relationships than just a simple linear hierarchy. We might also want to be able to start talking about optional trust relationships. Maybe they're from a ship that's from a ship owners association, some internationally recognized body, and we want to be able to provide more trust to them. We just don't want to limit our accessing our BTS to only ships represented by some organisation. Everybody needs some navigation. But maybe we want to be able to say that if they can provide this trust, we can provide a higher tier of service for those that are prioritising or meaning that they can access certain routes or something like that. And the other ones for the ship I'm not going to go through because they're effectively just repeats of previous relationships. We're just illustrating that we can form these quite large, complex webs of trust relations. So, for our demonstration, we're going to demonstrate three different ships coming through the system. The first one is just going to be as I presented, where it's going to be trusted by all of the various different trust hierarchies that I presented. We're then going to send one that's effectively exactly the same, but it's not got this optional shipping association with it. So we can demonstrate that, yep, it doesn't need this. And then finally, we're going to demonstrate a pirate, who is just someone who we've just chosen to say that one of the trust relationships is maybe that they're registered with a flag of a certain country. Pirate doesn't have that, even though they may be operating a ship that is still using perfectly valid navigational system. It's still got that trust. Just because it's missing one key part, it's not going to be able to access our system. Okay. And we're going to demonstrate this as a system called White Sands, which has been previously demonstrated, and it produces a very nice graph like this, which you'll just have to take my word that this is the same graph as I showed on the nice slides, and hopefully should justify why I made some nice slides showing what this is. Because this isn't intended to be shown to the users, this is just a proof of concept system, and this is how this works. So, what we can do is we can go in the BTS. And so what I'm doing here is I have got my two components, my BTS and my ship. And as part of establishing a connection, we can establish a connection where we're now saying to the BTS, okay, anybody who wants to, so I could have done this on my phone or something, but it's just easier to show through this. Anyone who is wanting to connect, we can just copy over our QR code. And we have successfully connected. So we get a nice click, and we've connected successfully. Okay? And that's for our ship who's been trusted by everyone. But if we still want to be able to register with an unregistered ship, of course, is exactly the same, but it doesn't have that optional relationship. So when we pop this over, try and make that connection, sure enough, successfully. And then look, we've got finally, we have our pirate ship, which is exactly the same, but it's just missing one trust relation. We get both now. We cannot both. So what we've shown here is that we can form these kind of complex trust relations where it's not that we're having to, not that our ship needs to trust every BTS system all around the world, it just needs to trust a couple of trust groups, and these in aggregate, when presented to other actors, are what enable our different